Hello everyone, welcome to my channel. I am Umapati. Today we'll explore one of the simplest and most important sorting algorithm, selection sort. Before learning selection sort, let us understand what sorting means. Sorting means arranging data in a specific order, ascending or descending, so it's easier to search and manage. It's important because sorting makes searching faster and forms the base for many advanced algorithms. Selection sort is a simple algorithm that works by repeatedly finding the smallest element from the unsorted array of the array and putting it in the correct position. You can imagine dividing the array into two parts, the sorted part and the unsorted part. With each pass, the sorted part grows. Let's look at the step-by-step process. First step is to find the minimum element in the unsorted part. Swap it with the first unsorted element. Move the boundary forward. Repeat the process until the entire array is sorted. Let's trace selection sort using an example. Here we have taken an example like an array of size 5. The elements in the array are 3, 5, 2, 4, 1. We can say that these elements in the array are unsorted. So by following the steps of selection sort, how the implementation of selection sort works. The first step is to find the minimum element from the unsorted array and place it in the first position. Here the minimum element is 1, so we swap it with the element 3. So the array will become 1, 5, 2, 4, 3. Here in this array, the 1 is sorted part of the array and the rest is unsorted part. From this unsorted part, we find the next minimum element and swap it the first position of unsorted array, that is 5. So we swap 5 with 2. Then the array becomes 1, 2, 5, 4, 3. Here the sorted part are 1 and 2 and the unsorted part are 5, 4 and 3. From 5, 4 and 3 we again follow the same step. We find the minimum element here, that is 3, and we swap it with 5. So we get 1, 2, 3, 4. Now the array is fully sorted. This is how the selection sort works. Let us see the implementation of selection sort in C program. In this implementation, we are taking two nested loops, one to select an element and one to find the minimum. After finding the minimum, we swap it using the temporary variable. So here in the first loop, it starts from 0, so the min index at the start will be 0. And in the j loop starts from I plus 1. If I equal to 0, then j equal to 1. So here array of j, that is 1, and array of min index, that is 0. Here it compares like 65 greater than 25. So it satisfies the condition. Then the min index is changed, that is it becomes j, that is now j is 1. That means min index will become 1. And after other loop, the of j, that is j is incremented. Now j value is 2. Now min index value is 1. So again we compare 25, 12 less than 25. Yes, it satisfies the condition. So again min index will be 2. After that we compare in the same way with 22 and then with 11. Now here 11 is the main element. So in min index we store 4. So here the min index will be 4. So we swap using the swap condition. We swap it with the first element. In this way the implementation of code will run. Here we can see on the first pass of the iteration the 11 is swapped with the 64, and this is the sorted array, and this is the sorted, and this is the unsorted. From this unsorted we again select the smallest element, that is 12, and we swap it with the 20. In this way the sorting process is completed. Now let's see the time and space complexity of selection sort. Here, as we use two nested loops, so always the time complexity will be n square in the worst case and the best case, whereas the space complexity will be 1 as it is implemented in the stack and no main memory is allocated. So the space complexity will be 1. Let's see the advantages and disadvantages. The advantages are selection sort is simple to understand, works well for small data sets, uses minimal memory, and the limitations are slow for large data sets as the time complexity is n square, not stable, and outperformed by modern algorithms like quicksort or merge sort. Thank you for watching.